Coordinate geometry, finding the equation of a line.
Equation of a straight line. We have seen that given a linear equation, we can represent it on a graph with a straight line. However, we may want to reverse this. In other words, given a line on a graph grid, we may want to find the equation that represents it. For example, find the equation of the line in the diagram. Well, to solve this, we've seen that the equation of a line can be written in the form y equals mx plus c, where c is the y-intercept and m is the gradient of the line. So all we need to do is find out what is the y-intercept and what is the gradient. Well, we see the line crosses the y-axis at 1, so c is equal to 1. Now if we draw a triangle under the line, we see that the base is 1 and the height is 2. Now we know the gradient is the height over the base, which is 2 over 1, or 2. So m equals 2. So if we substitute m as 2 and c as 1, we get the line is y equals 2x plus 1. The equation of a line crossing the y-axis at C. If we can see in a diagram where the line crosses the y-axis, that's C, and the gradient of the line m, then we can write down the equation of the line by substituting m and c in the equation y equals mx plus c. This sometimes makes it easy to write down the equation of a graph. So let's look at another example. From the graph, write down the equation of the two lines. Well, for line 1, we draw a triangle under the line. Now we see the base is 2 and the height is 4. So the gradient is the height over the base, which is 4 over 2, or just 2. And the y-intercept c is 4. It crosses the axis when y is 4. So the equation of the line is y equals mx plus c, in other words, y equals 2x plus 4. If we look at line 2, we can draw a triangle under the line. Now the base of this triangle is 3, and the height of the triangle is 2. But the line is sloping downwards, so the gradient is the height over the base, which is 2 over 3, but minus, because it's sloping down. And so the gradient m is equal to minus 2/3. Now we can see the line crosses the y-axis at 3, so the y-intercept c is equal to 3. Substituting those into y equals mx plus c, and we get the equation is y equals minus 2/3 x plus 3. Or if we multiply all the way through by 3, we get 3y equals 9 minus 2x. Now, we may not be able to see what the y-intercept is, so let's find the equation of a line passing through a point with a given gradient. So suppose a line passes through the point x1, y1 and has gradient m. Then, if we choose any point xy on the line, the gradient from x1, y1 to xy will be m. If we draw a triangle underneath the line, we see the base is x minus x1 and the height is y minus y1. Now the gradient m is equal to the height over the base, so it's y minus y1 over x minus x1. So multiplying both sides by x minus x1, we get y minus y1 equals m into x minus x1. Now this is the general equation of the line passing through a given point with a given gradient. So let's look at an example. Find the equation of a line passing through 3 minus 5 with gradient 2. Now to solve this, we have x1 is equal to 3, y1 is equal to minus 5, and m is equal to 2. So we just substitute those numbers in our formula, y minus y1 equals m into x minus x1. And that gives us y take away minus 5 equals 2 into x take away 3. Now take away minus is plus, so y plus 5 equals 2x minus 6, and if we subtract 5 from both sides, we get the line is y equals 2x minus 11. Now another common situation we find ourselves in is trying to find the equation of a line when we're given that it passes through 2 points. So, suppose a given line passes through the points x1, y1 and x2, y2. We can draw a triangle under the line. The base of the triangle is x2 minus x1 and the height of the triangle is y2 minus y1. So the gradient, m, is y2 minus y1 over x2 minus x1. Now the line passes through x1, y1. So, using the formula y minus y1 equals m into x minus x1, we can write down y minus y1 equals the gradient y2 minus y1 over x2 minus x1 times x minus x1. And if we divide both sides by y2 minus y1, we get y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. Now this is a very useful formula for getting the equation of a line going through 2 points. Some people write it as y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. You can use whichever of those two you prefer. One thing to bear in mind, though, is the gradient of a vertical line is not defined, so we can't use this formula if the 2 points are one vertically above the other. The equation of a vertical line is of the form x equals b, where b is the distance from the y-axis. We should use this when the 2 points are one over the other one. So, remember, if we know the y-intercept c and the gradient m, we can write down the equation of the line as y equals mx plus c. If we know the gradient of a line m and one point that it passes through, x1, y1, then the equation of the line is y minus y1 equals m into x minus x1. If we know 2 points, x1, y1 and x2, y2, that the line lies on, then the equation is y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. So, if we look at an example, from the graph write down the equations of the lines 1 and 2. Well, line 1 is horizontal, so all the points on line 1 have a y-coordinate of 3. So the equation of the line is y equals 3. Line 2 is vertical, so all the points on the line have x-coordinate 2, and so the equation of the line is x equals 2. Now in part 3, we have to find the equation of line 3. Now we notice the line passes through the points 7, minus 1, and 3, 10. So we can use the equation of the line y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. And we have x1 is 7, y1 is minus 1, and x2 is 3, y2 is 10. Substituting, we get y take away minus 1 over 10 take away minus 1 equals x minus 7 over 3 minus 7. Well, that gives us y plus 1 over 11 equals x minus 7 over minus 4. Now, if we multiply all the way through by minus 4 and by 11, we get minus 4 into y plus 1 equals 11 into x minus 7. Multiplying by minus 1 on both sides, we get 4 into y plus 1 equals minus 11 into x minus 7, which gives us 4y plus 4 equals minus 11x plus 77, and subtracting 4 from both sides, we get 4y equals minus 11x plus 73. Let's look at another example. In part 1 it says, find the equation of the line passing through 7, 9 and 13, 7. Well, if we use the equation of the line y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1, we have x1 is 7, y1 is 9, x2 is 13 and y2 is 7. So y minus 9 over 7 minus 9 equals x minus 7 over 13 minus 7. In other words, y minus 9 over minus 2 equals x minus 7 over 6. And if we multiply both sides by minus 2 and 6, we get 6 into y minus 9 equals minus 2 into x minus 7. Dividing by 2, we get 3 into y minus 9 equals minus 1 into x minus 7. So 3y minus 27 equals minus x plus 7. And adding 27 onto both sides gives us 3y plus x equals 34. Now we can see what this looks like by drawing a graph. We can mark the points A, 7, 9, and B, 13, 7, and then draw the line going through them. Now in part 2, we're asked to find where the line crosses the y-axis. Well, if x is equal to 0, then the equation 3y plus x equals 34 becomes 3y equals 34, and so y is 34 divided by 3, or y is 11 1/3. So it crosses the y-axis when y is 11 1/3. And this appears about right when we look in the diagram. Now in part 3, we're asked to find the midpoint C of AB. Well, we can use the midpoint formula, that is, x1 plus x2 over 2, y1 plus y2 over 2. And we've got x1 is 7, y1 is 9, x2 is 13, and y2 is 7. So the midpoint is 7 plus 13 over 2 and 9 plus 7 over 2, which is 20 over 2, 16 over 2, and so the midpoint is 10, 8. We can mark this point on our diagram. Now in part 4, we have to find the equation of the perpendicular bisector of AB. Well, we're going to use the formula. The gradient is y2 minus y1 over x2 minus x1, and first of all find out the gradient of AB. x1 is 7, y1 is 9, x2 is 13, and y2 is 7. So the gradient of AB is 7 minus 9 over 13 minus 7, which is minus 2 over 6, or minus 1/3. Now the gradient of the line that's perpendicular to that is m, where m times minus 1/3 is equal to minus 1, and so the gradient is 3. So the gradient of the perpendicular bisector is 3, and it passes through the point 10, 8. So using the equation of the line y minus y1 equals m into x minus x1, for the perpendicular we have y minus 8 equals 3 into x minus 10. Expanding the brackets, y minus 8 is 3x minus 30, and adding 8 to both sides, we get the perpendicular bisector is y equals 3x minus 22. We can also draw this line on our diagram.